My name is Jeremy Adkins, and this is an instructional video on testing for dissolved oxygen content in water using the Winkler method. In March of 2016, a fish kill occurred in the Indian River Lagoon on the Atlantic coast of Florida. Thousands of fish died due to low concentrations of dissolved oxygen in the water. Brown algal blooms created conditions which depleted the water of dissolved oxygen. Warm water fish need a minimum of 5 milligrams per liter dissolved oxygen. Fish begin to die when oxygen levels drop below 2 milligrams per liter. Testing for dissolved oxygen content reflects one important factor of the health of our waters. Low oxygen levels could negatively impact tourism, fishing, and public health. Today, we will be using one of the more common tests for dissolved oxygen, the Winkler method. The learning goals for this video are to understand the steps of the Winkler method, become familiar with the chemical reactions associated with the process, and be able to interpret if the measurement is indicative of a healthy water system. The chemical equations for the Winkler method for dissolved oxygen are 1. Manganese sulfate plus 2 potassium hydroxides plus potassium iodide yields manganese 2 hydroxide and potassium sulfate. 2. Simultaneously, the manganese 2 hydroxide reacts with oxygen and yields manganese 3 hydroxide. 3. The manganese 3 hydroxide then reacts with sulfuric acid and yields manganese 4 sulfate and 3 water molecules. The manganese 4 sulfate reacts with potassium iodide and yields manganese 2 sulfate, potassium sulfate, and iodine. 4. Finally, 2 sodium thiosulfate and iodine react and yield sodium tetrathionate and 2 sodium iodide. Next, I will explain the steps of the dissolved oxygen test. This image shows the necessary equipment and solutions. These instructions are simplified and not to be used for executing the test. To better illustrate the chemistry behind each step, I will use ionic equations. First, you must fix the water sample to prevent the oxygen from reacting. Add 8 drops of the pink manganese sulfate and 8 drops of the alkaline potassium iodide azide. Manganese 2 ions from the manganese sulfate solution and hydroxide from the alkaline potassium iodide azide form a white manganese 2 hydroxide precipitate. As the manganese 2 hydroxide precipitate forms, it immediately reacts with the oxygen and water to form a brown manganese 3 hydroxide precipitate. Next, add 8 drops sulfuric acid and slowly invert for a minimum of 3 minutes. The sample is now fixed and must be titrated within 4 hours. 2 manganese 3 hydroxides react with 2 iodide ions and 6 hydrogen protons from the sulfuric acid and yield 2 manganese ions, 1 iodine, and 6 water molecules. The free iodine is produced at a rate of 1 iodine molecule for each atom of oxygen. The iodine then reacts with an iodide ion and yield triiodide. The second step is titrating the dissolved oxygen sample. The titration is done by adding drops of sodium thiosulfate and using a starch indicator. The triiodide reacts with thiosulfate ions from the sodium thiosulfate and yields 3 iodide ions and 1 tetrathionate ion. The total amount of sodium thiosulfate added to the sample is equivalent to the concentration of dissolved oxygen. Warm water fish need a minimum of 5 milligrams per liter dissolved oxygen. Most fish become stressed when dissolved oxygen levels drop below 4 milligrams per liter and fish begin to die below 2 milligrams per liter. Using our Winkler method results, you can indicate if the water has enough oxygen to support fish life. This image shows a healthier lagoon than the one shown at the beginning of this video. The general process for testing dissolved oxygen included fixing the water sample and titrating the water sample. You should now understand the steps of dissolved oxygen testing using the Winkler method, be familiarized with the chemical reactions associated with the process, and be able to interpret if the measurement is indicative of a healthy water system.